Welcome to my first physics lab where I explore objects moving at a constant velocity. In this lab, we utilize Newton's first and second law to predict motion. The first law of motion says that an object will move at a constant velocity unless it's acted on by an unbalanced force. An unbalanced force means that the net force is not equal to zero. Newton's second law is a quantitative law because it uses an equation to predict future velocity or future position. We utilize Newton's first law in this lab to show that the hamster ball is moving at a constant velocity. There appears to be no outside interaction, so the ball is moving across the floor at a constant rate. Newton's second law is used in the computer code to help us predict the motion of the hamster ball. Here's a video of my hamster crouton rolling across the floor. As you can tell, it appears that she is moving at a constant rate. We used Tracker to analyze this video. The ball is used as a reference for future frames so that we can predict the motion of the ball. The coordinate system is set so that the origin of the ball is at the center of the ball in the initial frame. We could have used other options as the origin. For example, the origin could be above or below the middle of the ball. This would change the y-axis, but the ball would still appear to move at a constant velocity. We could also have the ball moving in a negative x direction. This would cause the slope to be opposite to what it is in my video. There would also be changes if the ball was moving along the y-axis, but I'll discuss that later. Here's the video being analyzed in Tracker. I trimmed the video because the ball is accelerating and decelerating at the beginning and ends of the video. The slope is also not exactly perfect, and I will explain why that will be later. Here's the code I used to create my computer model. First, I created the object to analyze and created a graph to analyze it on. I set the ball equal to the mass of the ball equal to 10.5 because this is the mass of the ball and the hamster combined. The initial position and velocity in lines 34 and 35 are derived from the Tracker code. They're in the x position because the ball is moving on the x-axis. If I were to say that the ball was moving along the y-axis, I would put the number in the y component. In line 38, I set the initial time to 0 and the time step to 0.1. I wanted to choose a small time step because we are doing an iterative prediction of motion. This is because we're using a while loop. A while loop allows us to update the position in very small time steps. This is something that would be very tedious for us to do if we were using pencil and pen. I chose 1.4 to be the time in which the code stops predicting the motion. This is because this is the last time step in the Tracker video. The net force in this video is set equal to 0 because it's moving at a constant velocity and there are no outside forces acting on the ball. The velocity of the ball is predicted in line 57 where net force is equal to 0, meaning that the velocity is constant. And in line 59, the position is predicted by multiplying that velocity by your time step and adding that to the position from the previous time step. Line 62 updates the time step, and line 68 and 69 graphs that. Here's the computer model created by that code. Here is the graph where I compared the slope of the graph created by the computer model and the graph created by the Tracker model. As you can see, there's slight variations. This is due to it being hard to predict the center of the ball and to the hamster not being able to move at a constant velocity because it is a hamster. As you can read, their slopes are almost exactly the same, so we can say the object is moving at a constant velocity. In conclusion, we can say the object is moving at a constant velocity because we used a computer model where net force is equal to 0 and see that the lines are almost exactly the same. We also know that croutons are not the only force acting on the hamster ball. We know that there's also friction and gravity and many other forces. But we don't know how many pushes and pulls are acting on the ball. We just know that they cancel each other out. And that's the only thing that we need to know in order to say that the object is moving at a constant velocity. Thank you for learning about these concepts with me.